I'm Madeleine Coyle. I'm speaking from London today. I am working in the UK Railways and part of the Presidium for the UEIV. The talk today is about railway innovation, a young engineer's approach, and we will have 3 speakers today discussing their perspectives and projects that they've been working on. I will give an introduction now to the UEIV. It is in German, and I have still failed to be able to pronounce it correctly, so I will do the English translation. It is a union for European railway engineers, and we have 3 main aims as that union. One is to connect people, the next is to share knowledge, and the last is to certify people. And so the aim of these talks is to do the first 2 really, to connect people and to also share knowledge across Europe. I think it's great that we can do this now and just discuss railway topics from the ease of our own home. So before we start the presentations, we couldn't have done this without our sponsors. So we have 2 sponsors today, Plaster and Teurer. Plaster and Teurer are an Austrian family business and have been synonymous with technological innovation and cost efficiency in track construction and maintenance for 70 years. With the introduction of the first fully electric tamping machine, Plaster and Teurer has been proven its position as the technology leader in the global market, and currently emphasizes its aim to offer railway systems substantial support in digitalization of infrastructure. A lot of big words in there. We also have someone joining us today, Fabian from Plaster and Teurer, on our panel, so you'll be able to ask him lots of questions if you have any about their company. So, and also we have Global Rail Group, who are a railway consulting company. They promote growth and drive innovation for local, regional, and global rail infrastructure managers by creating, pooling, and transferring unique rail knowledge. So, without further ado, we will go on to our first speaker. The structure of today, if you didn't hear it before, is we have 3 great speakers today, all aspiring young engineers, and all of their topics are very different, but with a theme of innovation. They will describe a project that they've been working on, and then at the end we will open it up to the floor and have a discussion about what they've been talking about, and go from there. So you're welcome to put your questions in the chat as we go through the presentations, and then at the end you can either say the question yourself, or I'm happy to read it out, and we will ask the speakers their advice and answers. So yes, without further ado, we will get started. The first speaker is Laura Quinney, who is a seasons delivery manager. Laura is going to be talking about drone use in autumn, which I'm sure there are signalling engineers on the call that will appreciate that this is a big, a hard season for a signalling engineer and also the railway. So a bit of background around Laura. She joined Network Rail in 2015, working in maintenance, and has been in a seasons-based role for approximately 5 years, and has gone into the operations side of that. She was a seasons delivery specialist and is now a seasons delivery manager, and is involved in all aspects of seasonal and weather event preparations, particularly from an operations perspective. So, and looking at the impact of the autumn season on the railway, hence the title. So yes, really looking forward to this one. Take it away, Laura.
Thank you, Madeleine. Good afternoon, everyone. Good evening, everyone. as Madeleine mentioned, I'm Laura Quinney. I'm the Seasons Delivery Manager at Network Rail within the Central route. I'm just going to share my screen. This into presentation mode. Okay, and hopefully you can all see my screen okay.
Yeah, all good, Laura.
Okay, brilliant. So first of all, just to give you a bit of a background on where we got to with drone usage during autumn. It's something that we introduced for the first time last autumn, so autumn 2022. And until probably this time last year, maybe a little bit later into the spring, it isn't something that we had considered using. But it was something we initially discussed in late spring 2022 and initially completed some trial flights during the late spring and early summer, just to understand whether it is possible to identify railhead leaf contamination from the drone usage, from the images, and as well as understanding the quality of the images that were available from some sort of the various drone models that we had access to. So a number of flights were completed. Following the completion of those flights, we identified that, yes, it was possible to identify leaf contamination on the railhead, particularly using the DJI Matrice 300 drone, sorry, along with the H20T thermal camera. That drone and that camera provided the best quality images, although there are some limitations, which I will come to a little bit later on. But that drone provided both video and photo images that were clear enough to identify what was leaf contamination, but what was sort of pigmentation on the railhead. So following those flights, we then my autumn response leads then attended a drone course in July 2022, and following a period of training within the UK rail industry, within Network Rail, once you have your drone pilot's license, there is a requirement then to be assessed by a Network Rail pilot, which then once you pass that assessment, newly qualified pilots are then able to fly over the infrastructure. And for us, those assessments were completed in September 2022, just in time for the start of the autumn season. Just to give you a bit of a background on some of the types of incidents that we experienced within the UK rail network during the autumn season, the ones that we tend to monitor are signals passed at danger, station overruns, wrong side track circuit failures, reports of low adhesion, and freight slipping to a stand. Now, you'll notice for autumn 2022, we've seen a reduction across all KPIs, and the use of drones has played a part in that. It isn't the only thing that's contributed to the reduction. There are some other changes that we introduced last year that helped to reduce those figures, but drone usage is one part of many different things that have contributed to that improvement. The biggest focus that we've seen this year and the biggest improvement has been on the occurrence of wrong side track circuit failures during the autumn season, particularly around our rectification times for incidents. So as well as being able to use drones to proactively respond to incidents and go and view the railhead and confirm whether railhead contamination is there without disrupting the train service, without having to put staff physically out on the ground. The drone pilot is able to stand in a position of safety and fly the drone over the affected area, and then share those images with our signalling colleagues to confirm and ascertain whether it is railhead contamination that has caused the failure. And once confirmed, we can then proceed to treatment. They're using the drone and being able to provide footage and images to the signalling teams and the signalling engineers, so almost on a real-time basis. That means that their teams we don't have to wait for their teams to arrive on site to then take a line blockage and request access to the track to go and inspect, we're able to use the drone to do that for us in a far quicker time. And then also, once the treatment has been completed, use the drone then to confirm that all of the railhead contamination has been removed. So you see from the rectification times, we've seen a significant reduction in the rectification time for autumn 2022. So in the previous season, in autumn 2021, the average rectification time across our whole route was standing at 478 hours, so around about 20 days. And through the use of drones, and again, use of drone isn't the only reason for the reduction. There are a couple of other variables at play, but the use of drones was one contributing factor to reducing our rectification times to less than 24 hours in autumn 2022. In terms of successes and challenges, so a couple of the successes I've noted already, but there is an ability to inspect more of the infrastructure in a shorter time frame. So I've got some photographs coming up in the next few slides, which talk through some of the locations that we've inspected proactively and reactively. Some of them would have been harder to access on foot, as we would have done in previous years. So we have that ability to inspect locations in a far shorter time frame, but also cover a greater distance. As mentioned, there's no requirement to take a line blockage to fly the drone. There are restrictions in how low the drone can be flown over the infrastructure, but with a powerful camera, you're able to zoom in to the railhead, so the height of the drone doesn't play too much of an issue in getting good quality images. But being able to do that without taking a line blockage to access the track, not only are we keeping our team safer, we're also providing a safety and performance benefit to the UK rail network. As I've mentioned, where we have wrong side track circuit failure incidents, that there's no requirement for signalling teams to attend site to confirm that it's railhead contamination that has caused the failure, as we're able to share the images, so that has an impact on their workloads as well. And as I've mentioned, sort of an improved rectification timescale for all KPIs. So we were using the drones in response to all of our KPI incidents, not just wrong side track circuit failures. In terms of challenges, so as I've mentioned, the M300 drone can't be used in the rain, so there are constraints around when it can be used depending on the weather, but there are other options available, which I will come to a little bit later on. The purchasing of the drone equipment themselves can be expensive. Again, this does depend on the equipment purchased, but there can be quite a significant cost implication depending on which model you choose. And for autumn 2023, within the UK, there have been some changes to the Civil Aviation Authority legislation, which will have some impact on some of the approaches that we've taken this year. So we just need to spend some time understanding how that will impact upon our processes. And that legislation will vary across Europe as well. What the legislation that we have here in the UK might not necessarily apply in other countries, but it's just something that we need to be aware of and adapt our processes to be compliant. The next few slides then are just some examples of where we've proactively completed drone inspections, and I'll come on to some reactive inspections shortly. But this first location is a location in the West Midlands within the UK at Sutton Park. So as the name suggests, this is a line that runs directly through a very leafy suburban park. It is a freight only route, but it is a known area for wrong side track circuit failures and also for freight services slipping to a stand. So at this location, we don't have remote monitoring fitted, so we don't have the technology at this location to be able to almost pre-warn us where wrong side track circuit failures may be occurring. So this is one of the locations where we pre-planned drone inspections to go and inspect the railhead and therefore, if contamination is found, take measures to remove and potentially prevent an incident. And I do have an example in a few slides' time of where contamination was found at this location. Similar example again, this time at another location just outside of Birmingham. Again, it's a known area for wrong side track circuit failures. Remote monitoring is fitted at this location. But again, given the number of incidents we have had at this location in the past, whilst we will get some level of indication where leaf contamination may be building up from the remote monitoring, proactive drone inspections are also completed just as a additional measure to check that the railhead was clear and there were no potential issues developing. Similarly, again, a location again within the West Midlands, a place called Darlaston Curve. So again, this is a known area for wrong side track circuit failures. We don't have remote monitoring fitted, so again, it was another location that was chosen for proactive drone inspections to check whether there's any leaf contamination building up, and therefore allow us to take action to remove that and mitigate against any potential developing issue. Continuing the proactive inspection theme, this time we're getting in a little bit later into the autumn season. So for this particular example, we're now at the end of October. So in the UK, this would be coming into our peak part of the autumn season. And this time, this inspection was completed on the 29th of October, again over Sutton Park. And this time, level 2 contamination was found. So within the UK rail industry, I'm not sure whether it's similar across other rail industries, but in the UK, we measure our leaf contamination, railhead contamination at 3 levels. So level 0 is no railhead contamination, building up until level 3 contamination, which is the most severe. So in this example, level 2 contamination is found, and in the picture on the right you'll be able to see what looks like a thick black line of contamination down the middle of the running band. So that was identified as level 2 contamination. That image was taken by zooming in using the drone. So the drone at this point would have been about 70 or 80 meters in the air. And it is that the powerfulness of the camera that was fitted to the drone that was able to zoom in and take such good quality images. So with this particular example, the contamination was identified, and then the autumn response lead was then able to take action to arrange for our autumn railhead treatment train to treat the area at a slower speed to provide a more intensive treatment and remove the risk of an incident occurring. And at this particular location, we didn't have any incidents during the whole of the autumn season. Similarly, again, another location, this time again within the West Midlands area, just outside Birmingham, another high-risk wrong side track circuit failure site. Had many failures in previous years. So in autumn 2021, there was 3 failures at this particular site. Again, through the proactive inspections, detecting of potential issues using the remote monitoring, and then using the drones to go and inspect, we didn't have any wrong side track circuit failures at this location in autumn 2022. Moving on to reactive drone inspections then. So this is where we've had a wrong side track circuit failure occur. So in all 3 examples, this is where wrong side track circuit failures have occurred, and we've used the drone proactively to inspect. So this first one at the end of October was a multiple failure involving 8 separate track circuits in quite a remote location. And we used the drone to go and inspect the track circuits after the failure had been reported by the signaller. The autumn response lead went out and took the images of all 8 track circuits and shared them with our signalling engineers who confirmed that based on the the traces from the remote monitoring and also the images that provided by the drone that it was leaf contamination that had caused the failure. That then allowed the autumn response lead to take appropriate action to clear the contamination and then fly the drone over again to confirm that the contamination had cleared, shared those with the signalling lead, who was then able to confirm that the track circuits were now showing as behaving normally and therefore could be returned to normal working. And this particular incident was resolved in less than 24 hours, which for a multiple wrong side track circuit failure is a significant improvement on previous years, where we would have seen this issue probably rolling on for a couple of days at least. Next example, again, very similar location, this time in another suburban area of Birmingham, in the West Midlands. So another high risk wrong side track circuit failure. Team was able to respond using the drone to share the images, no requirement for S&T to be on site. They were able to share the images before and after the treatment. And for this particular example, normal working was resumed within less than 3 hours, which was helped to reduce signaller workload, as well as signalling engineers' workload by not having to attend site with the autumn response lead, gathering all the information and sharing that with the teams. Final example, again, another location. This time we're almost at the end of the autumn season in December. Another high risk known area for wrong side track circuit failures. With this example, using the approach taken in similar approach taken in previous examples, this was returned to normal working in less than 8 hours. So there are sorts of differences in the times that's taken, and there are a number of variables at play for that. But as a on the whole, a vast improvement on where we've been in previous years. Just to sum up then on sort of our next steps. So for autumn 2023, we're planning to build upon the success of autumn 2022. Whilst that season was a massive success for us, there is still further work that we can do to improve further. As I mentioned, we've got some work to do just to understand how the CAA legislation has amended and how then we then need to amend our processes, and we'll be working within the National Air Operations team within Network Rail to do that. We've also purchased some new drones to add to our fleet. So we already have the M300 drones. We've now also purchased the M30 drones. So these are much smaller than the M300s, but the picture quality and the image quality is as good as the M300, but you can fly this drone in all weathers, which removes the challenge that I mentioned earlier. We're looking to introduce nighttime flights as well. So we started to trial this at the end of last autumn, and from the image on the screen you can see that the quality of the image, whilst not as crystal clear as daytime, it's good enough to be able to identify where railhead contamination is developing. So it'll be something that we'll be looking to do for this year, and we're also having discussions around how we can further extend our drone usage in regards to seasonal issues throughout the other seasons of the year. And that's everything from me. Thank you all for listening.
Oh, that was great. Thanks, Laura. Really great presentation.
No
and
problem.
as someone that doesn't know much about railhead contamination, I really enjoyed that. I was surprised by the image quality and how much, like how great it is even from such a height, like unreal.
It is,
and also the reduced rectification times, and with less and less access to the railway, what a great thing to use. So really appreciate you coming on today. Yeah, so thank you. Unfortunately, Laura can't stay, but Laura, are you happy to be contacted if anyone has any questions about your presentation.
Yes, that's fine. No problem at all. I will pop my email address in the chat if anybody wants to get in contact with any questions. Please feel free to do so, and I'll get back to you at the earliest opportunity with an answer. But thank you all very much for listening today, and look forward to hearing from you in the future.
Cool. Thanks, Laura.
Thank you very much, Madeleine. Thanks all.
Right. Our next presentation is a step in a different direction. So we now have Elena Crespo talking to us. So Elena is from Global Rail Group. She is a manager in Global Rail Group and will be talking to us today about the optimization of infrastructure asset management through digitalization. Got the word right that time. So Elena is part of the consulting unit for the Global Rail Group and leads projects for the optimization and digitalization of railway infrastructure asset management and maintenance, with a strong focus on track geometry and ballast bed condition, speaking my language, and has more than 6 years experience in the railway industry, has worked in Platter and Toira, and also worked in development of smart systems for monitoring and the evaluation of ballast condition during the tamping process. She is very passionate about the railways and believes that rail transport is the key to a more sustainable and inclusive society and a more efficient mobility. So without further ado, over to you, Elena.
Thank you very much, Madeleine, for the introduction. So let me share my screen.
Yeah, we can see that.
Yeah,
go ahead.
You see that? So if I'm going to talk about digitalization in railways, first, I want to describe the context in which the railway industry is right now. And for that, I like to use this statement that says as follows: railways are undergoing its biggest transformation since its creation. Without taking into account the last few years, the infrastructure management has been a very traditional area in railways. We have seen in the meanwhile how other industries have been adopting new technologies to optimize their processes and improve the results. But for railways, that is something that is starting a bit later, and is right now when we can see that infrastructure managers are starting to use the potential of new technologies and to use them to improve the processes in the asset management area. And what is this happening? For me, one of the facts that make this happen is that Europe is committed to rail as an alternative to the current mobility model, both for passengers and freight. And to put some figures on the table, the European Commission aims to double the number of high-speed trains passengers by 2030 and triple it by 2050, and to transport at least 30% of all goods in Europe by train. That means that we will see new needs in the industry, in the railway industry, and rising traffic means, on the one hand, that we will need infrastructure to be in better shape than ever, and on the other hand, we need an increase in capacity. This increase in capacity is not possible to do with a traditional approach of maintenance, because with this traditional reactive of preventive maintenance methodologies, for increasing capacity and increasing traffic, we will need an increase in maintenance also. That will increase the track outage, and that will result in a reduction of the capacity. That is the opposite of the goal that we are pursuing here. So from Global Rail Group, we think that the good approach to do it is to have a smart asset management methodology. For this new methodology, we need to use the technologies that are available in the market right now, which are not specific for railways, but that we have seen that in other industries, they are having good results and they are improving the methods. So railway infrastructure managers have to be aware of the fast pace with which the IT world is developing and changing. These new methodologies bring new possibilities, and their potential must be used. So for some in other industries, even the word I'm using here in this presentation, this digitalization term, will sound a bit old-fashioned, because right now we have in the market enough technologies to provide automatization instead of digitalization. Digitalization for me means to transfer documentation that was in the past in paper to a digital format. So now we are in the age of automatization. We have to automate the derivation of objective conclusions from this data, and to assure that this is doing in a proper way with traceability and in an accurate way. So I wanted to bring here one example of the technologies that we have introduced to our projects. This is business intelligence. We have used it mainly in projects related to data that describes the condition of the track. So business intelligence is both strategies and technologies that try to merge the data analysis of domain-specific data. In this case, will be data about the condition of the track, like, for example, track geometry. And we merge that with business information coming from other areas of the company that are not directly linked with the maintenance, but that have some influence in the cost or in the efficiency of the maintenance. So, for example, that will mean not to consider just track geometry data, but also financial data, data about the resources, like, for example, maintenance machinery and personnel, and data about the maintenance registry or the measurement registry of the data. So the business intelligence approach is not something specific for railways, but this approach aims to support decision makers by means of collecting different sources of data and provide objective conclusions that evidence the actions that are needed to be taken in the organization or in the maintenance strategy. And for that, we need the proper environment to make this work in the proper way. I want to explain that in a very high level, because if we drill down in every area, that is getting too complex. But we could say that it starts with the data sources. So we, as I mentioned, we have different data sources, the ones that are related directly to the condition of the track, and sources that are generic corporate data. Then the most important part for me is the data storage, because when starting a new environment for business intelligence, it's crucial to have the proper data storage in order to assure the traceability of the data, to assure that the data is immutable, and to have some, to have control on the versions of data and control on the access. So this data storage will provide the proper environment in order to consume the data by the data analytics. And with data analytics, we can understand different things. We can apply just simple maths, like, for example, we can take the thresholds of the EN 13848, that is the European standard for the track geometry quality. Or we can provide some specific algorithms like statistical calculations, like the standard deviation calculation that is also in this standard. And in a further step, we could even apply artificial intelligence. The last point will be the visualization, and the visualization must be adapted to the different users and stakeholders that are in a company in order to support the decision-making process for the different levels of the organization. So, as I mentioned, we aim here to do automation. So here is the automated processing pipeline for measurement data that is feeding this business intelligence environment that we have created for many of our projects. So the first point will be to gather different sources of measurement data. The second point will be to transfer this data to the right format to be used, stored, and to easily find our data in our system. The third step will be to do the data enrichment. So as I mentioned, the potential of the data is much higher if we mix this data with data coming from other areas, like the ERP of the company, the financial data, with data about resources and different registry information. And the next point is to provide on top analytics. And this analytic processing is to apply the logic that we use to describe the condition of the tracks. So as I mentioned, that can be very simple, just to compare the signals with some thresholds, or even that could be to apply some predictive algorithms. The next step is the data model transformation. So once all the calculations have been done, we automatically, these calculations are fed in a data model that fits the online analytics. As we normally use commercial off-the-shelf tools. So to fit this online analytics, we need a special structure of data that is not common for other tools. And with that, we can create, as I mentioned, the last point, that is the dashboards. So for the dashboards, we want to consider different stakeholders in every of our projects. So the basement of the pyramid, if we consider, for example, track geometry, the basement of the pyramid will be the infrastructure engineers. These users want to analyze and to understand every single issue in the infrastructure. So they want to see the measurement signals of every meter or every 25 centimeters on the track in order to identify the issues, the single issues that they have when a threshold is passed, and to understand the correlation between different signals, for example, between the alignment and the longitudinal level signal of the track. The second step will be the infrastructure responsible. So this level is more focused on the safety, because this level is the one who has the responsibility to assure that the operation of the network is done in a safely way. So for this, they are not they don't have the time, and they don't want to investigate on every single issue on the track, but to have an overall view on the condition of the track and see how this condition affects other areas in the organization. And finally, we have the top management level that is more related to see in a very generic and holistic way these different issues about the track, like safety, sustainability, capacity, and cost. And with that, they can do things like optimizing the allocation of budget to see which areas are consuming most part of the budget, and to better allocate or to better decide what to do with the network. So business intelligence is crucial in the creation of these different users, because the data sources and the tools used have to be the same for the three levels. That means that if we identify an issue on the top management level, we can drill down and to see in the basement of the pyramid how this issue is affected by different issues in certain meters of the track. And then I would like to show some dashboards that we have created. Well, this is not a real dashboard. This is a demo dashboard. I apologize, but due to confidential issues, we are not able to present here a real dashboard. So I have tried to bring here the different approaches and the different levels that we consider when creating our dashboards. This is just one example. I have taken here the alignment signal and the longitudinal level signal in order to make it easier for different people with different background to understand it, but we can adapt it to the different needs of our customers. So in this, hope you see my mouse. This first top management level dashboard, we have here the degradation of the track. Of course, it's very constant because, as I mentioned, it's just a demo, it's not real data. So we have considered here the track quality classes of the EN 13848 standard. This is a European standard. And we can see how the evolution of the track has been since 2019. So here the worst quality level was not very present in the network, but it has been increasing with the pace of the years. The second approach is to see the single defects, so the points of the track that are passing different levels of thresholds with different severity. And then we can see also these different thresholds, these different track quality classes in the track. So in the y-axis, we have the degradation of the track, and in x-axis, we have the kilometer points. It's a pity that I'm just presenting screenshots, but the application allows to drill down and to interact with the data so that we can see different kilometer points and different length of sections. And also we can modify here the years that we are considering. And as I mentioned, the potential of the best potential of business intelligence will be to mix this data with some financial data that I'm not able to present today because due to these confidential issues. But that will mean that we could see the budget that has been allocated every year to the maintenance strategy, and we could see how this increase in budget or decrease in budget will be correlated with the condition of the track. So the second dashboard will be the infrastructure responsible level. And here we can see an overall description of the condition of the track. So based on the same standard, we can see the kilometer points that are passing different levels according to their severity, and we can see the distribution of the track quality classes also in all the track. It's possible to consider different time frames with the widgets that we have in the dashboard, and also to consider different incremental points. And if we drill down, we could also select the severity level that we want to investigate. And the map is easy to identify where these issues are exactly in the reality. And the last level will be the infrastructure engineer level. That means that it allows the engineers to investigate every single meter or every 25 centimeters of the track. It also allows to drill down in order to see sections with a higher length or lower length. And it also allows to classify the condition of the track based on the track quality classes of the 13848 standard that are based on the standard deviation calculation. So this is just one of the cases that we have applied to our projects, but of course we can customize the dashboards to the needs of our customers. So this has been everything from my side for today, but in case you have any doubts or any questions, don't hesitate to contact me by mail.
Oh, Elena, thank you so much. That was brilliant. I think, yeah, that would have pricked the ears up of the track engineers in the room about alignment and showing a kind of whole view of our track geometry data. And it was great to see the demo of it and how your dashboard works. And we'll save the questions till the end and keep everyone on their toes. But yeah, thank you very much for that presentation. That was brilliant.
Thank you, Madeleine.
Right, we've got our last speaker now, last but not least. We have Aymeric presenting. I'll just share my screen again. Aymeric is presenting from Austria today, right, Aymeric?
Exactly.
Yeah. So, kind of again on the big data stuff. So Aymeric is presenting about how to find a needle in the haystack, big data and improved log analysis for everyone. Aymeric is a trainee at Thales Ground Transportation Systems. He has an undergraduate degree in computer science and digital communications and is now pursuing a master's in data science. He has been at Thales Ground Transportation Systems for about a year and has started off in engineering environment and support tools, looking at tooling and scripting, and is now working on big data and data analysis. So there's a lot of people excited for this presentation, I'm sure, Aymeric, so take it away.
Thank you very much. I'll just share my screen as well. I hope you can hear me well and you can see the presentation well.
Yeah. Can hear
well,
you. All good.
Perfect. Well, hello, everybody. As already presented, I'm Aymeric Hollaus. I'm a 25-year-old trainee working at Hollaus. And today I have the honor to talk to you about a project that I'm working on and am passionate about. This project is an innovative solution designed to analyze and interact with large amounts of data and login data, which are generated by our signaling elements. As also already said, I'm an undergrad in computer science, and aside from my work at Hollaus, I'm currently pursuing my postgrad in data science, hence me being so motivated by this project. I have been working at Hollaus in Austria for slightly more than a year now. And yes, so in addition, of course, I would like to thank the organizers of this event for offering me this opportunity today and to the other speakers as well. But before I talk about my project, I would like to briefly introduce Hollaus as a whole. Hollaus, as you know, is an international company. We're offering and maintaining multiple solutions across multiple domains, such as ground transportation and mainline signaling. Here in Austria, we're around 420 employees and counting, with a predominant engineering representation. Being a key research and development center, we actively thrive for improvements and new approaches to solve problems, which leads to projects such as the one I'm presenting to you today to emerge organically. Here, one can see the integrated solutions we offer and maintain. The solutions that are developed and maintained here tackle multiple facets of mainline signaling, such as electronic interlocking, train control system, train management systems, and various other. Our integrated log analysis environment, sorry, it's a bit of a mouthful, is currently mainly catered to our trackside elements, route control systems, and complementary solutions, but it is not exclusive to them, and it offers us the ability to expand to our other systems fairly easily. So now about the project, the focus of my presentation today. This project, which we call Elena internally, is our pitch for an improved log analysis environment. As already touched upon, it came about organically and is currently in its early stages, meaning it's still actively being developed and is since shortly showcase worthy. Our products being mainly safety critical railway infrastructure control systems, such as trackside elements, they emit large amount of log data. And each of these data points contain information about system performance, potential issues, states, or just general communication. The goal of this project is to create a single environment that allows users to efficiently monitor and analyze said log data, enabling quick issue identification and diagnosis while providing insights into system behavior and patterns. Here in the slide, briefly above, you can see the general approach to analyzing log data. Our environment does not deviate too much from that, but enriches that process. So the motivation for someone like me is fairly self-explanatory, but as a whole, before this project, users had to run scripts and manually extract log data, making it difficult to correlate data from different sources and identify issues in a timely manner, which could lead to potential downtimes or reduced system reliability. This also facilitates the analysis of the systems for customers and engineers alike. The goal is to make complex information and data easy to understand for everyone and easy to expand upon. Not to say that experts can gain more from this, but also top level can also achieve something with it. We also determined that digitalization is the key for knowledge sharing. So what are the concrete goals that we have? So as the name entails, how to find a needle in the haystack. The reason behind that name is that we have big data. That would be about billions of data points for a single country. We want to find a single needle, a single use case, or even bigger patterns. Both of these are allowed in our environment. We want no need to search log files manually, as mentioned before with the scripts. We want an easy to access web interface to our data, making it accessible from everywhere you are. We also want to offer available examples as reference to do advanced analysis or how to perform these dashboards, similar to the presentation that was shown beforehand. I will briefly talk and mention some of them. We want to have these examples so that users, be it a field operative or an engineer or a developer, can gain something, some insights from this. The possibility of access to data is there, independent of the control of the product. And lastly, we want this to be a refined database for general queries. I'll go a bit more into that detail when I will talk about the architecture. So what is data we're even working on? The data we're working with stems from our products, meaning from interlocking and signaling systems. We utilize the fact that all our elements have access to a processor named DGP, that stands for Diagnostic Processor, to receive this data. This approach allows us to interact with historical data and with systems that do not have integrated digitalization features, which makes this fairly flexible and very usable for historical data. The line format, that's the bottom picture you can see, stems from its due to historical reasons, as some of our products are 20, 30 years old, and they kept this original format of this log data. And this comes from a terminal output. On the right, you can see how these used to be. And the format is still there, just now we process it digitally, as seen below. We parse these unstructured data points into something that is structured and queryable, something that is interactable. The data that we are working is being generated daily, and we store it permanently, just to have some image on this, so you can have an image on the size that we're talking about for a single country. For multiple stations, we would have about 2 to 3 billion data points. Each data point meaning one information, one event, one failure, one communication, one status update. So what are we working with? We're working with the stack, as you can see on the right. We're working with Kubernetes, which allows us for simple deployment and scaling. This is very adventurous for us, because if we want to expand our data sources or the processing or ingesting power, this is easily done through this environment. After it is all in this one single place, we'll move on to Logstash and Elastic. Logstash is a technology that allows us to handle this data ingest and give it meaning. So we will have a message in front of us, and it will look at it, assign a pattern to it, and then from there we can gain timestamps, informations, whatever field we want to define. Then Elasticsearch is our distributed search engine. The reason we went with this is to make big data fast and easy to query without big overhead. Lastly, staying in the same environment, we use Kibana and Jupyter to visualize and analyze our data. The Elk Stack and Jupyter Lab offer powerful and flexible data searching and analyzing that enables users to quickly and easily search, filter, visualize log data from multiple sources. One of the strongest aspects that our environments can offer is the creation of dashboards. They are easy to create, modularize, and are flexible and adaptive to the data selected. Due to that, they allow any kind of users to achieve or discover something, be it a manager or an operative. Here would be a general overview dashboard that one can access, and here one can see the amount of records we have, from where does our data come from, or mainly. And on the bottom left, this just says the data provenance. The holes meaning we did not get data from said station, and if it's a higher color, that means we have way more data from that station. It's a bit hard to see because we have quite a few of the stations here, but yes. Here, one can see a dashboard covering all signaling elements in a very high-level view. That would be elements such as a switch, such as an axle counter, such as a relay signal. This data here at the bottom, you can realize a trend. There's a big dip here. For the people in Austria, I would gladly ask you to maybe tell me what you think it is. You can write in the chat, but yes, I'll leave it at that. And as one can see, multiple uses can be fulfilled with dashboards alone. And some use cases were already fulfilled, where we even found software bugs, memory buffer overloads in some of the memory boards. We noticed patterns in switching times or in fan times, even patterns such as the having too much leaf coverage in fall, data overflows from certain stations. The options are there, and we want to offer an environment where users or engineers can fulfill these use cases. Dashboards are not the only tool we offer users. On the left, you can see this is how the environment looks at if you want to do general query. This data that we have here, as you can see, 2.6 billion data points. It is very easy to make a single question or single search to access or find certain elements, certain fields, certain patterns with just a query. Logical operations are already allowed in this search. On the right, this is an extension of our environment that would be Jupyter Lab. Here, these are notebooks that allow for a bit higher level analysis. Here, it's a bit much, but here I just decided to do something where we cannot see too much, but have an understanding of it. Here you can see fan switching times that we have for outside elements of signaling elements that we have. So here we can see if maybe a fan is overheating, if an element is maybe in a tunnel or not. A lot of analysis that is a bit more demanding in terms of statistical approaches can be done in Jupyter, but the Elasticsearch stack that we use, it also allows for even higher levels of manipulations, such as machine learning approaches, ML models. So who is interested in this? The target user base is, in general, engineers that want to tinker around, but it's mainly also for service centers and field operations. They are the ones that want to have a fairly quasi-live view. They want to know what happened today, what happened yesterday, exactly at that date, that single element. We also want to cater for employees that work within RAMs, RAMs standing for reliability, availability, maintainability, and safety. We want to cater for them, meaning that we want to show a lot of historical data. The more data they have, the easier they can figure out and present patterns. This is also relevant for product managers or customers, and as already mentioned, engineers that want to tinker around with the data. So what are some achievements and some prospective results that we have? The slide is fairly self-explanatory, but topics would be reliability, where we want to minimize the impact of potential failures, visibility, identifying opportunities for optimization and improvement, and faster troubleshooting, reducing general downtimes and improve system availability. The improved collaboration, streamlined log analysis, and customized dashboards, our environment already offers this out of the box per se. So what is the future for a project such as Elena? Well, we want to utilize such a project for excellent synergy with other technologies, such as asset management, making our data not even relatable, but you could also follow whole track size. Also, other approaches like machine learning offers even inbuilt in our environment quite easy to apply. We want to also make this fairly automatic and also integrate additional data sources and analysis tools to enable more powerful insights. That means other products that we have, maybe for train control management systems. So as a whole, what is the goal for the future? Ensuring reliability and availability of our solutions and continue to drive an ongoing optimization and improvement initiative. Thank you very much. Yes.
Thank you, Aymeric. That was brilliant. Another great presentation. I particularly liked your slide on having multiple target bases, because I think although engineers are probably your prime target base, we do need to, I think, make a dashboard that can be utilized by anyone, you know?
Exactly.
So,
yes.
Very interesting. Okay, now it's down to everyone. We're now going to do our Q&A session. So if anyone has any questions, please raise your hand and we can come to you, or put it in the chat and I will read it out. We've already got a couple already. And if we can spotlight our speakers, Charlotte. There we go. We've got Elena again. And also we have now Fabian Hansman, who is joining us from Passo Ventura. Fabian, do you want to introduce yourself before we get started?
Well, good afternoon, or actually good evening, everybody. My name is Fabian Hansman. I'm working for Passo Ventura. I'm Deputy Director of Marketing. My background is not really marketing, so I'm a civil engineer with a PhD degree in railroad engineering. Thank you for having me today, and thank you for giving me the chance to join this panel discussion.
Thank you, Fabienne. So I wanted to actually ask some questions too, as our theme is innovation, and I guess a question to all the speakers is: do you think how far do you think we've come in your time in engineering in your jobs? How far do you think we've come in terms of innovation? Do you think there is the right culture for innovation? And then the last bit is how can we encourage more innovation? Fabienne, I'll start with you. Just to put you on the spot, I think you're.
Well, picking me first is a little bit unfair. Well, I think railroads or railways are quite innovative. I think a lot of people underestimate railroads a little bit. I think considering that safety is our #1 priority, we should keep that in mind a little bit when it comes to innovation. However, I think the increasing demand on the standardization and homologation blocks innovation a little bit. I think the demand for homologation is getting bigger and bigger in the European Union, and I think the same also in Great Britain. So I think that is a kind of issue or concern that I currently have, is that standardization and homologation blocks innovative solutions for the future.
And so, putting you on the spot again, how do you think we can? Is there a way to overcome that?
Well, that's a tricky question.
Yeah, that's probably the question that we all want answered. But yeah, maybe Elena, what's your view on kind of innovation that you've seen so far? I'll give Fabienne a break.
Well, I fully agree with Fabienne that it's true that there is innovation in railways, but for example, I started in a consulting company of signaling for the design of new lines in Spain mainly. And it's true that for the design of new lines, for example, the BIM methodology is right now like a standard in the industry, but for areas like asset management, it's true that we don't have a standard in the industry. So we have seen how different companies are doing different things, but the approach can be very different. And I think that makes very difficult to share information among different between different stakeholders, or even if we consider the end-to-end maintenance process, different companies, different softwares and platforms are involved there. So this lack of a standard solution or a standard language among between software and platforms makes a bit difficult to improve in this area.
Okay, so just to reiterate, so you think do you want to have a standard language to improve, to kind of implement innovation, or do you think that's a hindrance now? Just to make sure I understand you.
Yeah, well, it's not. I'm not talking about a programming language, but I mean a standard solution, a standard methodology. Like for example, BIM in the design of new tracks, no, that has a approach that affects the different steps of the designing process. So the same should be done for maintenance and how.
Yeah, we like standards in the railway, so maybe that is the way, is use another standard process. Oh, very interesting. Thank you, Elena. Aymeric, what's your view that you've seen so far in your year and in your university experiences too?
In general, here it's I can only be lucky. There's a lot of innovation and at least thriving for that. I think in general, for my experience from a year, which is for some people not comparable with their 15 years, but from what I've seen is that in general, since our product lifetimes in general in train industry is fairly long, it's very hard to notice these changes. But I think if you keep being aware of it, looking at every project on the side, I do see innovation is being there, but it's just that maybe compared to other fields of engineering, maybe it's a bit harder to notice.
Oh, interesting. Okay. Is it harder to notice because are we not good enough at kind of showcasing what we do on the railway, do you think? Is that what you mean?
No, but as I said, it's since our products have a very long lifetime, and we thrive way more for maintainability and supporting such longer term products. It makes it a bit. It seems like it is a bit short on the upkeep, but it's I would claim that it's not the case. But I think as a beginner, when you get in, that is maybe the first look you would have at it.
Yeah, cool. Fabienne, do you have an answer to the golden question, or shall we move on?
Sure. I would like to solve that issue. No, I think you cannot get rid of standards, okay? Because standards they ensure more or less that we can operate our railroad system in a safe way. So you cannot say get rid of the standards, because then everybody is doing whatever they want. But I think it would make it easier if we harmonize different standards. And it's easy said, right? We should not forget where we come from, especially in Europe. So we have a lot of standards. It was a diverse system, and we now try to build a single European railway area, more or less. But currently, it means that we simply take all the individual standards, and they still exist. So it makes it even more trickier. So it would make more sense to harmonize and reduce the standards, and not just take all of them and combine them, which makes it at least almost impossible to implement innovation. I hope that makes sense up to a certain extent. So it's not only combining, it's more or less also getting rid of it, see what's best, and try to find a standard, a European standard more or less, that is applicable in all the countries.
Yeah, I think that's a pretty good answer for that question, is having the standard for everywhere. And I guess everyone has their different problems, but also everyone also have similar problems, so being able to share that, like we probably don't know yet if we have the same problems. So this is what this is all about. So yeah, great answer. Right, I'm sick of my voice, so I'm sure everyone else is. So I will go to I apologize if I say your name wrong. Mijana, do you have a question for our speakers? You should be able to speak or unmute yourself.
Did you hear me?
Yes, we can.
Thank you very much. You pronounced me well. My short name is Mira. So
Mira, okay.
Yes, I'm coming from Serbia. From the railway, I'm working as a railway engineer in the Faculty of Transport and Traffic Engineering. So thank you very much for great presentations. I'm very happy to see the ladies in the railway sector. It's not popular for the ladies, but now I see we are now in the good number in this railway talk. So I would like to emphasize another issue besides standardization that you mentioned, that Elena gave me a very good hints with this beginning of the presentation, with this quoting about innovations, that new innovations such as digitalization, transformation, big data also imply culture shift that affect people process. And I would like to add education as well. The people who work on the railway now needed to do something more in their education, in some sense of reskilling or upskilling. Because if we wanted to apply these new innovations like digitalizations in asset management, and also Aymeric said using the big data, we need to have the people who knew to apply that or manage with that in the railway. So I would like to use only a few minutes of your time to say that in Erasmus there is a project called Staffer that now aim to identify current and future skills requirements and to support education and training establishment in their effort on curriculum adaptation and mobility programs for applying this innovation in the railway. So maybe it's very interesting for all the people who listen all this innovation to know that also Now, another point is the people who work on the railway and their educations. So I must also add in the end that our faculty, also the member of this staffer projects, and we have a 31 company consortium. One of them are the Siemens, Alstom, CAF, Mafex, Unife, so really a broad scene are covered with this project, and we are looking on the trend and innovation in the railway, and on opposite of that, how to make new skills and reskilling or upskilling.
Brilliant.
Once again, Diane, thank you very much for a good presentation, and see the innovation and the applying in the railway.
Thank you.
Thank you very much.
Yeah, Elena, have you anything to say? Are you happy? It was, I think, good
Yeah,
compliment to you.
I fully agree that technology is developing and changing at a very fast pace. So it's crucial to have education, not only for the young generations, but also for all other generations, because it's something that is changing every day, and that we have to know the state of the art of the different technologies.
For sure. Anyone else to discuss? I think it does go on Fabian's point as well, is that we are constantly evolving, and therefore our standards must evolve too. So very interesting. I will go to the next person. I think Daniel, would you like to ask your question? You should be able to unmute yourself, and you can even turn on your camera. Ah, here he is. Hello.
Here I am. Hello. I'm Daniel Wirth, the Secretary of the Union, and it was an innovation first presentation. And my question is, did you have image processing software for their analysis, or did you plan an imaging processing software for the future?
Is that to a particular person, or is that to anyone that wants to answer? Aymeric, or has anyone got a answer to it about image processing?
It's not my presentation, my project, but in general, I think it would be better if maybe Ian, I think, would speak about it, working there, maybe saying something.
Well,
Yeah.
Oh,
sorry.
I'll have a go at this one. Yeah. So yeah, Ian Puckering from Network Rail, so UK. So we are looking at image processing, and again, it's I put something in the chat after the first Laura spoke with the use of the drones for the rail contamination application. So we are doing a lot of work using CCTV forward-facing footage from trains to detect changes in line-side vegetation conditions. So predicting growth of line-side vegetation in proximity of the overhead line system. So it's in its infancy, but we're capturing data and overlaying machine learning algorithms on that data to allow us to focus our vegetation management program, which especially with the climate change that we're experiencing, the rate of growth is increasing considerably. We've noticed that over the past 5 years, and predict that it'll only become harder and more costly to manage that. So to go at it in a much more insightful way would be a real win for us. And I don't see any reason why we can't use the same approach with the build-up of railhead contamination. Aymeric's got his hand up. I think I've inspired him.
Yeah,
Thank you very much.
I was just wondering, this data or this machine learning, do you yourself create these data, or like these data points? So do you collect yourself by going through multiple times, taking snapshots, and then from that data modeling your own things, or are you using any open source things or other data sources are you use?
So we're in the way it works in the UK is so a lot of the train companies now have imagery collecting equipment on the trains that they are sharing with us as infrastructure, and then the train companies themselves are now getting to the point where they're doing a lot of machine learning techniques with their data, but also sharing that data readily with us, such that we can employ our own techniques. It's really interesting. I mean, we could go down a rabbit hole here with how we should be sharing data across train and infrastructure and wider than that in our industry. Data itself is a currency, isn't it? And we all like to think we own our own data and can be reluctant to share it to the people who really need it and are good at manipulating it. But we've certainly, over the past 2 or 3 years, I think the industry in the UK, it's got to the point where it recognises that we have to share data if we're going to move forward as a collective. So the answer is the majority of it is from the train, and our train operators are now sharing that. We have adopted a process of putting iPhones on the front of trains, putting cameras, just fixing, bolting them onto trains, anything to capture footage that we can manipulate locally. But high def footage and thermal imagery is obviously the better data source that we go for first time.
But it's creative at least.
Yeah, right. Sometimes it's the simplest solution that helps us. So yeah, great. Thanks, Ian and Aymeric. Elena, Fabian, do you have anything you want to add to that? Do you have a similar thing where you work? Have you the imaging processing side?
Well, we just have one example. So we use usually cameras, for instance, or the information from LiDAR sensors on some of our track maintenance machines. So we can we process data on the machine on the fly with edge computing. So we can get information from are there any obstacles in the track? So we identify obstacles or we identify sleepers. And based on more or less the identification of the system, the machine is actually developing a suggestion for the operator. So the operator can automatically, or the machine is automatically positioned different working units. And the only thing the operator has to do, the only thing is more or less to confirm the proposed suggestion of the machine. And then the machine works more or less half automatic. So we are using the information from LiDAR sensors and cameras. We analyze, or the machine is analyzing the information automatically, and then operates the machine half automatically, I would say.
Very cool. Thank you. That's great insight. Thanks, Fabian. I'll just read out some of the comments that we've had throughout the presentations too. We have Gunther Grunnert, who says, I'm very happy to see the data merge for tracks. We have similar built data fusion at Deutsche Bahn for bridges, timetable data, which train goes over which bridge, dynamic and static calculation of the bridge measurement data. But he said this presentation is high level and very inspiring, which is great. I think there's a lot of things that were talked about today. Before I forget, I will say that we have I will put in the chat the young member section form we've talked about this already, and I guess we see the value in talking across countries is this young member section I'm creating, and I'm recruiting members. So anyone is welcome to join. I will put the link in the chat, and you are also welcome to contact me. I'll put my contact in there, and we can go from there. And I will, if anyone just wants any more information, please let me know. It's very much the start of something, but I think just the idea is just to share knowledge and to just chat about our own experiences and work out how the railway works and work on it together. But we'll share this now. That should work. Ian, do you want to have you got a question?
Yeah, do I have time for one more question?
You do, yes. We'll take this as the last one.
Brilliant. It's a question for Aymeric. I couldn't help myself. I'm a signal engineer in a past life, and I've always thought that you mentioned that you use the interlocking data to feed your platform, which is great to see, because I've always thought with the introduction of the modern computer-based interlockings that we have controlling a lot of the railway, that we don't use that tremendous amount of interlocking data in a particularly insightful way. We tend to use it in a very basic way and look at it after something's happened to prove that what we thought was the root cause is the root cause. Whereas I've always thought we could use it in a lot more of a predictive and a condition-based a way to rather than going out into the infrastructure and fitting loads of sensors and IoT stuff everywhere to try and, this data is control information and a lot of what's the word, condition data coming back into the what I call the computer brain that operates the signaling system. So I'll be interested in how close you are to these are big data sets, goes without saying, when it comes to how many commands and stuff that goes out and into the system. How close are you to introducing the machine learning algorithms over that to give you a level of prediction into what the overall condition is of this railway system?
It mainly depends on if we want to use approaches like supervised or unsupervised data. So if we were talking about utilizing label data, this will need more and more domain knowledge. So more and more engineering helping our cause, working on labeling and fitting these messages, because as you said, it's quite a lot. Whereas for unsupervised, where we have unlabeled data, this is going more and more faster. So there is already built-in integration in our system. So now the only thing that's left for us, it will be to apply it and see how much it will compete with, for example, in other causes for statistical analysis, more for historical reasons. But I really like what you said before with the data, because a lot of people are thinking of adding sensors or more and more data, whereas with this log data, it's mainly used for development purposes in the past. There's so much more you can gain from it. So we were sitting on a gold pot, so it would have been waste not to use that and utilize that.
Spot on. Thank you very much. We'll be in touch.
Thank you.
You've also got someone else, Ian, asking Julian about NR, Dracus and Francas data for componentry will assist. I'll leave you to talk offline though. We'll leave this as the final question is, I'm going to try. First, Nick, do you want to say your...
Okay,
hi.
Okay, can you hear me properly or not?
Yes, can hear you.
Okay,
yeah.
Hi, my name is Aymeric, to be precise. Greetings from Poland, from southern part. I'm working for Attractech. It's a company which produces mostly sleepers, but also turnouts, so rather infrastructural parts. And I do have a question for Aymeric, because during your presentation, you said that you're using DGP. And my question is, to be honest, I've never come across this phrase, because right now I work in a project which is based on DSPs, like digital signal processors. And my question is, did you mean digital signal processor, or? And that's the first thing. And second thing is, I'm going to ask you for tips or trick, because right now our idea is to actually we have got let me say a test version of our product. Our product is made to analyze. We're using accelerometers, piezoelectric ones. We are installing them on the turnouts, and we want to analyze the vibrations. We're using DSP. We're collecting a lot of data, because DSPs are, they're collecting like 100,000 of samples per second, and it's very needed by us to. Let me say that resolution is very required by us to analyze. The idea is to analyze what is happening when the train is passing by our turnout, for example, and we want to analyze if there is something happening underneath the head of the rail. And technically it is possible thanks to triangulation and using special patterns. And right now we're using fast Fourier transform, and then we're doing a lot of calculations, and my question is, do you have any tips or tricks how to manage such a big data? Totally. Right now, we are trying to adapt some machine learning techniques, etc., to make it, because the time is super quick and it's totally undoable by any person. So it has to be analyzed by its own. So the software has to be analyzing the data in the background. And do you have any kind of tips and tricks, for example, how to manage that kind of a data in such a short period of time? What kind of databases shall we use, etc.? Thank you.
Okay, yeah. The first question, DGP was correct. I don't know if I reiterated well enough. Sorry about that. But DGP is something that we use. It's a diagnostic processors that we use for our products. So each of our products will have access to the DGP to communicate with other signaling elements and every other systems we have. So that would be something that we use internally. And whereas with what you're saying is, I think it would be better if we maybe communicate privately or off the video, but it really depends on how you want to handle data. What is important for you? Would it be for you to store a lot amount of data and for a longer time and then applying analysis on that? Then I would definitely recommend approaches like this Elasticsearch cluster, which mainly relies on querying very quickly and making operations very quickly on bigger amounts of data. But then if the most important thing for you would be to interact with live data, it really depends on how fast you want the data to be interacted with, because tool sets such as Elastic also have other approaches that's called file beat, if you know it, to work maybe on more live data. But then the more and more you want for live data or lab data, you would have to create an environment specifically just for that, just to cater for that. And at the moment you want to tackle really big amounts of data and live data, the biggest bottleneck you would have would be your technology or your infrastructure. But that's very high level what I said. So I think it would be maybe better if we can just exchange, or I'll also send my email, put my email in the chat if anybody wants to ask, and I hope I can help or learn from you also.
Oh, brilliant. I think that just shows again, another example of two countries and people, getting advice from each other. So, which is the aim of this talk. So I think we've done well today. Oh, and the lights in my office have just gone off. Okay. We will leave it there. Thank you so much, everyone. And firstly, thanks to our speakers, Aymeric, Elena, Laura, and Fabian for joining us at the panel. I've really enjoyed today. It's been super insightful. I'll put my email in the chat if anyone wants to discuss anything. Another plug at our young member section. We will be doing more discussions like this. The plan is to just meet again and talk about a particular railway topic like track geometry, but it will be anything and everything. Suggestions welcome. So yes, thanks again, everyone, and speak to you soon. Another thanks to our sponsors, Plaster and Toira and Global Rail Group. Thank you so much. And our next talk, I believe, is in May. We will send out more information nearer the time. But yes, thank you all. Have a great evening, day, and speak to you all soon. Thank you.
Thank you, everybody. Have a nice day.
Thank you very much.
Bye-bye.
Thank you. See you. Bye.